Hi, today we're going to have a look at a question from the IB/HL physics curriculum on the Bohr model of an atom. So the first part of this question is a 1-mark question, and it asks us to deduce the equation for the velocity of an electron in circular orbit around a helium nucleus. Now, as it's in circular orbit, we should recognize the forces are balanced. So in this case, we can equate the electric force with the centripetal force on the centripetal force. Both of these equations are given to us in unit 5.1 and 6.1. So for the electric force, it's K Q1 Q2 over R squared. Q1 in this case can be the charge of an electron, so that's just E. Q2 will be the charge of the helium nucleus, which has 2 protons, so it'll have a magnitude of 2E. In this case, we're just equating the magnitudes, so we don't really have to worry about the signs. So we get K times E times 2E over R squared. The centripetal force will be mv squared over R. The next part of the question is just us equating them. So just be careful when you do that. They have asked us to calculate V. So we should get 2E squared K, or 2KE squared over R squared, equals to mv squared over R. Now, I'm happy for you to simplify them however you like. I would write, that really should be a V equals 2KE squared over m R squared, and then the R's will cancel, giving us V equals 2KE squared over mR, exactly as they have asked us in the question. The second part of the question would like us to calculate the total energy of the electron. So I'm going to start off by stating that the total energy is the sum of the kinetic energy of the electron and the potential energy of the electron. In this case, it's a good idea to note that potential energy will be negative, but we'll deal with that later. So first, to derive the equation for the kinetic energy, we'll just use half mv squared over r. This is also given to you in the data booklet, by the way. And for the velocity of the electron, I'm just going to use the first part of the question's expression. For the second part, I'm going to use the equation that they've given us in 10.2, which states that the potential energy will be K times the product of the charges. So in this case, that will be 2E squared over R. Now we just have to do an easy subtraction for them. So total energy should equal to KE squared over R, that's the kinetic energy simplified, minus, that should be a 2, minus 2KE squared over R for the potential energy. And then it's just a nice and easy subtraction, giving us negative KE squared over R. The final part of this question has asked us to predict what will happen to the orbital radius as the electron loses energy by emitting electromagnetic waves. So again, I'm going to refer to the previous part of the question here. As the electron emits electromagnetic waves, the total energy of the electron will decrease. It's always a good idea to refer to the previous part of the question, and because it's a 2-marker, we need a second part. So as a result of the total energy decreasing, the orbital radius must also decrease. And that brings me to a conclusion for this question. I hope you guys find that helpful. Thank you.